All right, so repeating myself again, because this recorder is terrible. What we have to do now, and I already gave you the hint here, so it's no longer a mystery, but I'll just leave it there. So our objective is to rotate the plane, which right now is the equator of our Earth, assuming it was vertical in orientation to the sun. But in truth, it's not vertical. It actually leans 23.45 degrees away from the sun, and sometimes it's toward the sun. But for us, we're going to start off away from the sun. And so to do that, we are going to rotate around the y-axis right here, and that'll give us our tilt. So long story short, and long story second time around even shorter, transform and Euclidean, instead of using rotate object in a plane, we're going to use rotate 3D, because that will ask us for a vector to rotate around, not just a center point in a particular plane. Okay, so that's what I've dropped in here, and it says transform Euclidean. So let's go over what it's asking for. It is asking for the geometry, right? Pretty much everything needs a geometry that's a transform. It'll ask for the angle, right? Measured in radians again. It will ask for the center point of rotation, and then it will ask for the axis of rotation. So our geometry is actually going to be the plane itself, right? Because we're going to rotate this plane, tilt it, so that we can use it as the axial relationship for our planet, right, when it's on the angle of declination. So the geometry is the plane, and what you'll see is that it kind of shot one up over there. That is because we're not actually, all the defaults right now are set to the origin, and the angle at 0.5 pi equates to 90 degrees. So it's rotating it around the origin from this position to that position, right? That's why it does that. But that's not what we want to do, so we're going to change that. To change that, we need to first set an angle. Well, no, let's not worry about the angle yet. The center point of the rotation, simply put, because a plane can also be read as a point, right? They're sort of interchangeable. So I'm going to put the plane as the center point, and now they're coincident. And then we need to set the axis. Okay, the axis right now, because I haven't set an angle, is going to, well, let's set the angle first. It'd be more dramatic that way. So we go to math and trig, and then radians, and then we can set a static, not a number slider, a static panel that reads 23.45. And that's because the angle of declination never changes. So we plug that into radians, and we plug radians into angle, and there it is, rotating around right now the wrong axis, right? Because it defaults to the z axis. So what do? We will take this plane and break it apart into each individual axis, and then pick which one we want to use. So remember on Tuesday I said that Grasshopper is a constant cyclical process of creating geometry, deconstructing geometry, and then reconstructing it into something else. That's exactly what we're doing right now on a micro scale. So we take the plane and we go up to vector and plane, and this one right here called deconstruct plane, right? So the vocabulary is all congruent there. So deconstruct the plane. And when you plug that in, nothing really changes yet. But the cool thing is you can deconstruct it into the point that's at the center. Doesn't really matter. I've never used that before. The x-axis and the y-axis and the z-axis. So we've identified already as a group that we want to rotate it around this green axis, which happens to be the y-axis. So all I have to do is plug the y-axis output into the axis input of rotate 3D. You guys are going to be a fun group, I can tell. All right. Cool. So now you can see that we are properly leaning at the angle of declination that our planet truly is from the sun at one point in the year. What questions do you have? Yes?
Where's that 23.45 that?
This is a panel. So if you go to params and input, or just right here, that yellow one, that's a panel. Panels are really cool, so get well acquainted with that one because we're going to use that a lot. I just made it really, really small. It actually looks more like this when you drop it in. You could double click it and type in.
Can you come around to troubleshoot?
Yes. Okay, so I'm going to leave this up and I'm going to come around and troubleshoot with you guys unless you have a general question.
If we wanted to not see the rest of the stuff and just do the actual...
Very good question. This is probably an appropriate time to introduce that. So before I come around and troubleshoot then, let's talk about, well, I've got all this stuff happening, right? I just rotated my plane, but now I don't need the other one because it's irrelevant. To hide it, you select that particular component, and you can right-click it and turn this preview off. And it'll show up as a dark gray. Some of them automatically show up as a dark gray, like radians. That's because it will never create geometry. There's no way that radians can actually produce geometry because it's just a mathematical figure. So deconstruct plane can. In fact, you can see the origin right there. That's green. I could turn that off. But here's another part of this, guys, that you should be very well aware of. If I wanted to get rid of all of the geometry or a group of geometry, I can middle mouse click, and it brings up this little quick menu here. Did you get logged in or no? You did? Okay. Yeah, so middle mouse click, and it'll bring up this little mini menu, and you can, up in the top right corner, and in fact there are so many other cool things that you can do with this, but I pretty much only use it for this. You can disable the preview of all the things that you have selected, so I can turn them all off like that. Or select them again and turn them all on. You'll get used to using that. It takes a couple times to remember that it's there, but it's very, very useful. Okay, I'll come around and troubleshoot.